All right, in the next two videos we're going to be talking about addition and subtraction. In this video we're going to focus more on addition strategies, and in the next video we'll focus more on those subtraction strategies. So the TEKS that we're working on are 3.4a and 3.5a, both readiness standards. When we look at the prior knowledge that students have of addition and subtraction, we see that students have been working on this concept of joining and separating since kindergarten. Then in first grade is where they really get into looking at the basic fact strategies like doubles, doubles plus one, making a 10, those sorts of strategies where they just can look at a fact and use one of those strategies to help them to determine the sum. Then in second grade is really where they start adding larger numbers. So in second grade, they add 2-digit and 3-digit numbers using a variety of addition strategies. And really in third grade, our job is just to continue the work that second grade did. So we're going to continue working with those exact same strategies and really hone in on help students figure out which one is most efficient for them and where they can get the correct answer. So we're going to review all the strategies they learned in second grade, and then we're just going to work on those towards mastery. Okay? So I think the most important thing to remember about addition and subtraction both, and really multiplication division when we get there, is that we have to take students through that concrete, pictorial, abstract progression. We really want students to have a good understanding of what we are doing with these digits, what we're doing with these numbers, why do I regroup, making sense of the process. So we have to take them through the progression. We can't just start out with standard algorithm and expect all students are going to get it. Because as we've talked before, a lot of students still do not understand the whole regrouping process, and it's very, very hard for them to understand. So we have to give them other strategies, and we have to be able to show them concretely, pictorially, why we ask them to regroup, okay? Also remember that standard algorithm is not to be mastered until fourth grade. So this year in third grade, you as a teacher cannot require students to add a particular way. You can say, okay, I want you to try open number line today, and then I'm going to allow you to work it another way as well. Yes, we're going to work on specific problems, but when you take something for a grade with addition, you have to allow students to be flexible in what strategy they would like to use. Okay? All right, so what we're going to do is we're going to start out concretely like I would start out. So we're going to start out, the most concrete way for students to learn to add is by giving them a place value mat and base 10 blocks. Okay? So you're going to start out and you're going to say, boys and girls, I'd like you to create the number 258 on your place value mat. So they're going to create 258 on their mat. And at the same time that I do this, I would also go ahead and have students do the pictorial model of drawing the base 10 blocks. And since our students are already familiar with all of these ways, depending on your class, you can even have them do the standard algorithm at the same time. And so we'll do that here. We'll look at all three. All right, so boys and girls, you've created 258 on your mat. So let's draw that base 10 picture. What would that look like? So we have 258. And I encourage you, anytime that you are doing your base 10 blocks or your pictures, that you work with students on making that row of 5 and then making that row of 3 to represent the 8. that making the row of 5 helps them think about this like a 10 frame. And they're used to 10 frames in the younger grades, so we can use that same process where they can automatically tell that's 8 instead of them just dropping down the blocks, okay? And even in their pictures, I can see that's 8 pretty clearly, a row of 5 and a row of 3, okay? Then I'd say, okay, boys and girls, I want you to go ahead and add 100. Oh, I'm sorry, I forgot a step. So then we can say, well, what does this look like in standard form? It's 258, okay? All right, boys and girls, then I want you to go ahead and add 100. Oh, got a 1 in there. Let's do 34. All right, I want you to add 134 to that, okay? So let's go ahead and draw what that would look like. 130. Okay. So we're going to add these together, boys and girls. How is it represented in standard form? There it is. Okay, we're going to add these together. So let's first look at the ones place. We're going to add up the ones place. I know this is 5, 6, 7, 8, 9, 10. So how many ones do I have? I have 12. Okay, and this is when you're going to talk to boys and girls. Well, can I just go ahead and put a 12 in the ones place? I want to think back to place value. How many digits are allowed in each place? Only 1, right? 12 is actually made up of 2 digits. It is the 2 digit in the ones place and the 1 digit in the tens place, okay? So I have 2 ones, correct? And then I have a group of 10. So what do I have to do with this group of 10? I need to put them all together, right? And add a 10 to the tens place, okay? So we're going to do that same thing with our picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can group those together. They're not going to be there anymore because I am adding a 10, okay? So how many ones do I have left? 2. Okay. Same thing here. When I added these together, I got 12. Can only have, so I have 2 ones and I have a 10. So I have to regroup that. So I can do all 3 at the same time. So let's add up our 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's see if I have 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I have 9 10s. 5 plus 1, or 1 plus 5 is 6, plus 3 is 9. So far, we're seeing all of it together. Then, how many hundreds do I have? I have 3 hundreds there. I have 3 hundreds here, and I have 3 hundreds here. Okay? So, concretely, one way we can show addition or do addition pictorially. So when you get rid of the blocks, if students still need those base 10 blocks, they can do the pictorial model of base 10. And of course, this is our standard algorithm. Okay. All right, so let's talk about another way to do it pictorially. Let me erase this for me here. All right, another way that we can add pictorially that students have been taught is using the open number line. So let me just do 207 plus 366. Okay, so let's talk about this on our open number line. And basically an open number line is exactly what it sounds like. Students draw an open number line, and they're going to start with 207. Okay, And what's great about the open number line is students can do it really however they choose to. When you start out talking about the open number line, you can use the base 10 blocks as well. So I can say I need to add 366 to 207. So I can get out my 366. I'm sorry if these are a little too hard to see on this without the blue paper. Okay, so there's my 366. And students can choose to do this either way. I can say, okay, well, let's do a jump of 100. Here's 100, right? So I'm going to get rid of that. I'm going to do a jump of 100. And what would that be? 207 plus 100 is 307. You can do another jump of 100 and get rid of that one. 307 plus 100 is 407. Okay, I have 166 left. So I can take out another 100. So 407 plus 100 is 507. Ooh, and then I have 60. And you can have kids do, you know, we're going to do a 10, and then that's 517. And you can have them do that, or hopefully eventually with your modeling, you can say, well, how many do I have left? I have 5. So that's 50. I'm going to do a jump of 50. What's 517 plus 50? It's 567. So students don't have to do one block at a time. They can, once they start getting that number sense and seeing that, I could have started here and said 207 plus 300. Some teachers have students do this and break 366 into expanded form. So they can do a jump of 300, a jump of 60, and a jump of 6. But some kids may need to see it this way at first, where you're breaking out piece by piece. Remember, both ways are correct. And if it is the only way students get the problem correct, breaking it out this way, then that is the strategy they need to use. Is it as efficient as jumping a group of 300, a jump of 60, and a jump of 6? No. But students can choose to do it any way that they choose. So from here, if I'm a student, I'm going to do 3 ones. I know I have 6, but I'm going to do 3 because that gets me to 570. And then I'm going to do my other 3 ones because that gets me to 573. And if they know standard algorithm, they can choose to check it with their standard algorithm. I always have students, when they do computation problems, do it 2 ways. So if you used open number line, then maybe pictorial model of drawing base 10 blocks is the way you want to check it. If you've done the open number line and you know standard algorithm, then check using that as well, okay? So that is open number line. Remember, the students are very flexible in how they do that. So when you model, just make sure you do it multiple ways. Make sure you do it where you stretch everything out. Put the base 10 blocks up there until students don't need them anymore. Then, next time you model, do the big jumps of 300, of 600. Then you could break 6 up into 3 and 3 and have them get to the friendly number of 570 and then move on to 573. All right, so we've talked about concrete with base 10, pictorial base 10 pictures, pictorial open number line, and we've already really kind of talked about the standard algorithm when we did it in that first problem. So let's talk about one abstract way students can add, which is called front-end addition. So when I get into larger numbers, I'm going to just do something fun here. Can you tell I like the numbers like 6, 3, and usually 7 are my favorites. So 612 plus 289. Okay. For front-end addition, what students do is they break up each of the numbers into their expanded form. Okay? So 612 becomes 600 plus 10 plus 2. 289 becomes 200 plus 80 plus 9. Okay? And then what happens here is students just add these together. 9 plus 2 is 11. 80 plus 10 is 90. And then 600 plus 200 is 800. Okay? So students can, from right here, say that it's going to be 901. Okay? But that might be hard for students to see, so they can always break up the 11 into 10 and 1. So they can say it's 890 plus 10, which is 900, plus 1, which is 901. So they can go straight from this, or they can break it down further to this. It just depends on the student. But what they're doing is they're adding the values of each digit up in both numbers to get the final answer. Okay, so I believe that is all the different ways that we taught kids in second grade to do addition strategies. So as I said, when you give students practice, just make sure that they're allowed to use multiple strategies. Since they are in third grade, as you teach a strategy this year, you can combine multiple strategies, like I said, concrete with the pictorial models, with standard algorithm. You could do concrete and then front and addition together. Just whatever it seems like your kids need. I know in the progression it says on day 1, give the students an addition problem and just see what they can do. See what your students do. Do 90% of them use standard algorithm? Do 85% of them use front and addition? So what is it that the strategy that they're coming to you with? And so then you'll know kind of where to begin with students when you're trying to teach them these addition strategies and working through them. All right, we will see you in video 2, and in video 2 we'll talk about the same thing. We'll just be talking about subtraction strategies.